Hey guys, welcome back. Today I thought I would do a video on finding out if a number is a perfect square. So if we get a number like 4, it returns true, 5 returns false, 9 is true, 100 is true, etc., etc. 105 is false, right? So let's start out. Square. And we are going to return a Boolean value. Let's return false, and we'll probably set it up so that if it's in a loop, we're going to return false, or we're going to return true if the loop finds something that we want to find. I equal 1. We don't need to set it at 0 because 0 times 0 is 0. I is less than input I plus plus. So this is a very sort of straightforward way to find out if an input is I actually, you only have one line. You do not need to use the braces in JavaScript for an if function. I think that's also true for and while loops as well, but I'm not sure. It rarely do you have an instance of those kind of loops needing only one. But so what are we doing here? Well, this is to the power of 2. You can do the math.pow thing. You could also just do I times I because it's squaring it. And then we've got strict equality to input and then return true. So if we do something like log is square, 1,000 should be true. Oh, 10,000 is true, 1,000 is false. Yeah. Of course, there's faster ways to do this. Obviously, you could just run a square root function and see if it, right, you could just say, math, you would return something like math square root input square root return and in that case, what that would do is you're rounding down. If it's already an integer value, it's just going to end up being the same. And if it's not an integer value, right, it's going to come back false. You could do something like that, obviously. A bit less interesting if you're trying to avoid using the math object, trying to avoid using, or if you're just trying to sort of like think about these problems and how to solve them, right? This is an easy way to do it. and less interesting. I think the square root function also tends to not be very performant because square roots are hard in general and therefore hard for computers. We can improve this though. Function. Let I'll start equal start plus end minus start divided by 2. So if your start value is 1, this is just going to come up with the 1 in 100 is going to turn 50, right? As your start value gets higher, though, you need to compensate for the fact that the bottom limit isn't 0. That's why you're adding start at the beginning and then subtracting it from end later on there. That's how you get the midpoint between any two numbers you take. If you want to get the midpoint between 5 and 50, 5 plus 50 minus 5 divided by 2, which, this is going to come out as an odd number, but by 2 plus 5. That's the midpoint. Rounded down is 27. When you were doing Cartesian coordinates, this was lurking in the background when you were trying to find midpoints of a Cartesian coordinate plane. So that's our midpoint. Right, we're just finding the square here. It's the same thing as this. If square then square is now. What we're going to do here are two situations: one where square is greater than the input, and one where it is less than. And if the square is greater than the initial input, then we have to decrement the end point. So we'll say end equals mid minus 1. And then we could say else if here square is less than. We're not going to though, because it's square is either going to have strict equality, be greater than, or be less than. We don't need to check to see if it's less than by the end. Start equals mid plus 1. So what's going on here? Let's say we've got an input of 50. The input of 50 is going to find the midpoint of 25. 25 times 25 is not going to equal the input. In fact, it's going to be greater than the input. So square is going to be greater than the input. That means we need to tick down a bit. So the end is going to be instead of 50 is going to be 25 minus 1, 24. Okay, so now mid is going to be the midpoint between 1 and 24, which is 12. 12 times 12 is 144. That's still greater than the input. We're going to do it again. We're going to get 6. We're now at 36, which means we're going to hit this because 36 is not greater than the input, and it's not equal to the input of 50. Getting close to the answer, so I need to make sure it'll kick back the right answer. So we've got 36. So now instead of, so the mid equaled 6. Now the start is going to equal 7. So we need to find the midpoint between 7 and 12, which is, I think it's 9. 9 minus 7 is 2 divided by, or sorry, not 9 minus 2. 12 minus 7 is 5. Divided by 2 is 2.5. Rounded down, that's 2 plus 2, or sorry, 2 plus 7 is 9. So our midpoint's now 9. 81, that's greater. So 8. 8 times itself is 64. That's going to be greater. Now what's going to happen? The end point is going to end is now going to equal the mid, which is 8 minus 1, 7. So now our start is 7 and our end is 7. And we're going to get 49. It's not going to be equal. And it's going to be less than 50. So now start is going to be 8 and end is going to be 7. So we're going to exit this loop, and is square also is going to equal false. So it's a lot more complicated than this, but what you're doing is cutting down the numbers that you have to check by a large factor. What we checked there was 7, 9, 6, 12, 25. Yeah, 25 and 50. In the first instance, we checked 1 through 50. There's a little bit more computation going on under the hood, but overall, log n compared to n. At most log n. And if you tried to compute the time with like benchmark JS or something like that, you would find that this one's going to run modestly faster when you're doing 121, and when you're doing a larger number, you're going to see bigger gains. Not something that you necessarily see a lot in JavaScript. One, because we've got a lot of libraries to help out with crap like this, and two, don't need to do a lot of math in this kind of thing, right? This is something you probably see more in like a C language. Number's a square, you can add 2 zeros, it'll be square, because you're just right, you're just multiplying each component by 10. So 7 times 7 is 49. 70 times 70 is 4,900, right? I could keep on going until I get to the max integer value, and then after that, it might have a conniption. yeah, it's having a conniption. Probably. Oh, it's still working. It's not. It's probably not happy under the hood. I could probably keep on going, and at some point it might kick back false because it doesn't. It won't be able to handle it. For now, it seems to be doing a fine job though. But yeah. Anyway, that's the video. I hope you guys enjoyed it. Always looking for new ideas. Maybe I'll start showing off some React things. I don't really do much front end stuff on this channel, obviously, but I mean, if you're doing JavaScript, that's kind of mostly what you do. But yeah, as always, I hope you guys enjoyed the video. Drop a like, hit the subscribe button, etc., etc., and I'll see you next time.